Through the window of our small commercial plane, a landscape unfolds that defies comprehension. Stretching to the horizon like a frozen ocean caught mid-storm, the southern Patagonian ice fields gleam blindingly white against the deep blue sky. Massive rivers of ice flow between jagged peaks, their surfaces cracked into labyrinths of crevasses that catch the morning light. I press my face against the cold window, trying to comprehend the scale of what I'm seeing. Having grown up in the Appalachians of the United States, I've never witnessed glaciers before, let alone one of the largest ice fields outside the polar regions. No photograph could have prepared me for this. The vastness, the beauty. As we fly over a particularly massive glacier, I notice something disturbing. Where the ice meets the water, a massive face has calved away, sending car-sized chunks of ice floating across a milky turquoise lake. The freshly exposed ice wall glows an almost unnatural blue. My mind fills with questions. What forces shaped these colossal ice formations? How quickly are they disappearing? What happens to the surrounding ecosystems as these frozen giants retreat? And most urgently, what does their accelerating melt tell us about our planet's future? To truly understand these vanishing giants, I'll need the insights of someone who has dedicated her life to reading the stories written in ice. Welcome back to Rewildology. I'm Brooke Mitchell, and today we're exploring one of the most spectacular and vulnerable landscapes on Earth. The glaciers of Patagonia, where massive ice fields have shaped both the terrain and the identity of southern Chile for millennia. Earlier in our journey through Chile's route of parks, we encountered the magnificent Great Glacier and Torres del Paine. But today, we're expanding our view to understand the broader ice systems of Patagonia, the massive northern and southern Patagonian ice fields that feed dozens of glaciers throughout the region. From the aerial perspective, these ice fields reveal themselves as vast frozen seas caught between mountains. While I experienced their grandeur firsthand during my flight to Puerto Natales, to truly comprehend their scientific significance and the rapid changes they're undergoing required expertise I couldn't gather during my brief visit. After returning from Chile, I connected remotely with Dr. Ines Dussaillant, a Chilean glaciologist whose groundbreaking research has documented the accelerating ice loss across Patagonia's glaciers. Her recent publication in Nature has revealed concerning trends about how quickly these ancient ice formations are disappearing. But Ines's journey to glaciology wasn't straightforward. As she tells it, she comes from a family where being a scientist was not the path to take. She was more likely to be a doctor or a lawyer or an engineer. Despite having a strong connection with nature since childhood, without family guidance toward environmental science, she had to discover this path herself.
I ended up finishing school and studying agriculture because it was kind of being in nature, but also a normal career for my family. And then it was through agriculture that I started learning more about nature. And at the same time, I started going out to the mountains and I became a mountaineer in the Andes.
Everything changed during an expedition to the southern Patagonian ice field to climb Mount Alam, a previously unclimbed summit. For 10 days, she and her team crossed the ice field on foot.
And there was a lot of time to walk on top of a glacier and seeing glacier landscape and nothing more. A lot of time to think. And it was like a lightning, I don't know, but just I became so sure that I wanted to study what I was walking on top of. So I wanted to study glaciers, and I wanted to study glaciers from Patagonia and understand the important role that they play, because at the moment I didn't. I just loved them, and some weird energy was pushing me to study and understand them. And now I really know that they are not only beautiful, but they are important.
This moment of clarity led her to France, where glaciology first began in the Andes through French researchers who came to Chile. Today, Ines works at the World Glacier Monitoring Service in Switzerland, where she takes observations from researchers around the world and creates a global picture of what's happening to glaciers. As she describes it,
So now what I do is I take not only the observations that I did in the Andes and that other people have done in the Andes, but there's many different researchers in different places in the world that study the glaciers of the regions using satellites and in situ measurements. And they give the observations to the World Glacier Monitoring Service. It's like an international database. I take all these observations and I made a global picture of what's happening in glaciers around the entire world.
soon she'll be returning to Chile to focus her expertise on the glaciers that first captured her imagination during that transformative expedition. Before diving into the specific challenges facing Patagonian glaciers, Ines helps us understand what glaciers actually are and how they function on our planet.
The best way of thinking as a glacier is thinking that it's a river that is frozen. So it's a river of ice. But in fact, what determines a river is that it's flowing water, no? So a glacier is also flowing, but very, very slowly, because the ice, it's a plastic material that flows, but you, at the human eye, you cannot grasp the flow, but it's moving.
Ines explains glaciers using a bathtub analogy that perfectly captures their delicate balance.
You have to picture it like a river of ice. In the glacier, what comes in is the snow of winter. And then what's coming out is the melt in summer. And what is important is that we have to think of a glacier as an equilibrium. Imagine that the glacier is a bathtub. Every year, through winter, it's like you open the water at the top of the bathtub, and there's accumulation coming in the bathtub. And then the glacier or the bathtub is going to get more water. And then in summer, when high temperatures come, it's like taking the bottom of the bathtub. And then some of this water starts going out. This is a normal process in a year of a glacier.
A glacier in balance receives the same amount of snow in winter that it loses to melting in summer. If it receives more than it melts, the glacier grows. If it receives less, the glacier retreats. To understand where glaciers exist, Ines explains two main conditions: precipitation and cold temperatures.
We need humidity coming from the atmosphere, and we need cold temperatures. And for that, if we are in the tropical regions, for example, which is generally very hot, these conditions we have only very high in the top peaks. So glaciers near the tropical region, they exist only very, very high in the volcanoes that are above 5,000 meters. And then as you go to the north in the northern hemisphere and to the south in the southern hemisphere, towards the poles, then you start having lower temperatures that go lower in altitude.
Glaciers exist everywhere these conditions are met. From the high peaks of Africa and South America near the tropics to the Himalayas, Alps, Andes, and mountain ranges of North America, all the way to subpolar regions where glaciers reach sea level. Glaciers serve as far more than just spectacular landscape features. As Ines explains, there are four crucial roles they play that affect both local communities and our entire planet. First, as Ines puts it,
I like to say that they are the sentinels of climate change.
they respond to changes in local climate and show us at a global scale that our planet is warming. When we see glaciers retreating worldwide, they're providing clear evidence of global warming in action. Second, these melting ice masses contribute directly to rising sea levels.
As we are seeing that glaciers are losing ice that was locked in the mountains, this water is going somewhere and is raising sea levels.
This isn't just a local problem. It affects coastal communities around the world and can lead to what Ines describes as movements of people and geopolitical issues. Perhaps most importantly for local communities, glaciers function as natural water storage systems.
So a glacier, it's like a water tower. It's a place where fresh water is stored in the mountains,
They play a crucial role.
sustaining the river flow at the last months of summer and in periods of drought when there is no more rain and no more snow.
In some regions, like the Himalayas and part of the Andes, the situation is even more dramatic.
Almost all the water that you can see flowing in the rivers is sustained by the melt of these glaciers.
Finally, there's a fourth role that scientists have only recently begun studying intensively: the geological hazards created when glaciers retreat rapidly, leaving behind unstable terrain that can create dangerous mudflows and floods, particularly threatening communities in mountainous regions like the Alps. To study glacier changes, Ines uses two complementary approaches. For fieldwork, scientists must make two crucial visits each year, first at the end of the winter to measure how much snow has accumulated, then again at the end of summer to see how much has melted away. By comparing these measurements, they can calculate the glacier's yearly balance. But to understand long-term trends spanning decades, Ines relies on satellite observations. Using satellite images taken years apart, scientists can reconstruct the topography of a glacier at different points in time and calculate exactly how much volume has been lost over the decades.
So what's happening year to year with a glacier? We use field observations. And with satellite, what we do is that we have a picture of the topography. So imagine it was the year 2000 and satellite takes a picture in time. With this image, I can reconstruct the topography and I will have the mountains and the glacier and have an idea of the surface of the ice. And then the same satellite comes in 2025, today, it takes another picture and I have another surface of the same glacier, but in different periods of time. And if the glacier has receded, there will be on top of the glacier a difference in elevation. So I will see if the surface was here in 2000, now the surface will be here. And this allows me to calculate the volume of change integrated into the entire glacier. And then I can calculate how much water the glacier lost in these 25 years.
Having established the global context, we turn to the glaciers that captured Ines's heart and mine in Patagonia. When Ines worked at the global level, she realized something remarkable about the Andes.
When I worked these past years at global level, and not only for glaciology, but also other climate systems, like hydrology or even climatology around the world, I see that the region in the Andes is still so unknown. It's like kind of forgotten for the world. Like if South America was not there, and this is what's making me come back now to study the Andes, because there's so much that still needs to be understood, and it's just such an incredible mountain range that covers all the latitudes of one hemisphere.
The Andes stretch from the tropics almost to Antarctica, creating an incredible diversity of glacial environments. And Patagonia holds a unique distinction.
One of the things that I can tell in terms of glaciers is that it's the only region in the world where nowadays we are seeing glaciers that are growing. So,
wow.
Yes, in general, yes, the Andes is losing ice, but there are one of the few glaciers in the world that are still growing. And if you go there, and this is mostly in Patagonia, I have been there, and the ice is eating the forests. So they can show us the impact of a glacier that is still growing. And this is incredible. The variety of things that you can see here It's amazing. So we have the glacier that has lost more ice in the entire world is in the southern Patagonian ice field, and it's next to the glacier that is growing the fastest. And we don't really know why.
Wow, that is crazy. Okay, yep, now I have so many additional questions. I love your country. I love Patagonia. I'm so fascinated by this part of the world. The formation of Patagonian glaciers depends on a specific climate pattern.
What happens in South America that allows these glaciers to form in the Andes is that the climate system is bringing the main winds are called the westerlies, and they are bringing the moisture from the Pacific Ocean towards the Chilean coasts. And then we have this barrier that is the Andes that is stopping this moisture. And what happens is the orographic effect. So this moisture is pulled by the air of the planet. It finds this barrier, it starts to go up. As it goes up, it condensates and it rains.
This orographic effect creates the perfect conditions for ice formation, with high precipitation and cold temperatures at elevation. Patagonia contains several ice fields, but the two largest are the northern and southern Patagonian ice fields. The northern Patagonian ice field is about 400 square kilometers, while the southern Patagonian ice field is much larger at around 12,000 square kilometers.
These are the most known, but these are not the only ones. We have more ice fields. One is the Gran Campo Nevado. We have the Isla Santa Ines, which is less known. We have Cordillera Darwin. And what happens here is that we just have the topographical conditions for ice to accumulate in a larger way.
But these current ice fields are remnants of something much larger. During past ice ages, Patagonia was completely covered in ice, and these ice fields were connected as one massive frozen landscape.
But if we go back in time to the glacial cycles of the Earth, during glaciations, where the world, due to physical reasons of the orbits of the Earth, the Earth gets colder, and then we have these glacial like ice ages. Patagonia was full covered of ice, and then the northern and the southern Patagonian ice field were together, and glaciers were flowing to the Pacific Ocean, and they were much bigger. So now we are in an interglacial state of the Earth, and all this ice has receded and it still stays in the northern Patagonian ice field, the southern Patagonian ice field, and then the other ice fields. But we have all these fjords that were made by these glaciers that before they were bigger. All the Patagonian landscape has been shaped by ice.
This explains the breathtaking landscape I witnessed from the air. Those dramatic fjords and valleys were carved by ancient glaciers far larger than what exists today. One question I couldn't resist asking Ines about was the stunning blue color of glacial ice, particularly visible in places like Great Glacier.
It has to do with physics of the material. When you have ice, as the ice that you put in your fridge, for example, you see it transparent or white because there are bubbles of air inside the ice. As the snow comes together and it compacts into ice, these bubbles of ice, they almost don't exist anymore. So this is what makes it different. When light comes in, the rays come in different frequencies that have different colors, green, blue, and red. And when the ice is compact and doesn't have these bubbles of air, only the red light comes in, and then the blue and the green is reflected. So we see it blue or bluish, greenish.
Now we turn to the sobering reality of what's happening to these magnificent ice formations. Ines's research, including her recent Nature publication, reveals alarming trends.
The important findings that we see there is that on these 5 decades, the first 2 decades, like glaciers around the world were behaving normally. There was some variation year after year, but if you took the long-term trends there, the glaciers were stable. They were not losing mass. They were losing a little bit, gaining a little bit, but very, very stable. And then after the 1990s, they start losing ice in a global way. In the different regions, it varies the reaction, but in a global way, after 1990s, they start losing. And then you see an acceleration.
The acceleration is dramatic in recent years.
1976 to 2024, where I have observations, on the last 6 years of record, we have had 5 years of record mass loss. So this shows the acceleration that we are seeing in the present years, and that is not showing any signal of deceleration. It's showing signals of acceleration.
Perhaps most concerning is what Ines calls the lag effect.
There's a lag in the response of glaciers. If we change things now, and by changing I mean global greenhouse gases emissions, it's something that needs to be global, and that's why we have to follow the Paris agreements and try that the global warming is not getting too high at the global level. But even if we stopped today, and then the planet won't get warmer than 1.5, which is where we are now, 1.5 degrees warmer than pre-industrial levels. If we stop today, the glaciers have a lagging response, so they are still responding to changes that were done in the lives of our grandparents and parents. So if we stop today, they won't start growing tomorrow. They will start growing in some more years. The difference that we can make is that if we stop now, we have to wait less years so that they start regrowing again. If we don't stop now, we just fuel the wheel so that we will never get to the moment where they are going to start growing, and then we will just lose all the ice in the planet.
This means that even with immediate global action, glaciers will continue retreating for years to come. The question is how much we can minimize that retreat. When I asked Ines about predictions for Patagonian ice fields, her answer was both scientific and poignant.
The predictions that we have from models show that they are shrinking, but it will depend on the scenario that we choose as a population to follow. So, as I was saying, if we stop greenhouse gases emissions now, then we make glaciers recede less. We can have more glaciers in the southern Patagonian ice field than in Patagonia sooner in time. If we don't, we will lose them. How the landscape will look in the next years in Patagonia, it will depend on the scenario, the climate scenario that we choose to follow.
But even in the worst case scenario, Ines offers a perspective that's both sobering and surprisingly optimistic.
Let's put ourselves in the worst scenario. We lose all the ice or most of the ice in Patagonia. It will have consequences, like every change has consequences. But it will also, if we see the good side, this ice will disappear and it will leave space free for new species to colonize. And the planet and nature is so plastic, it will find a way, and trees will come. And we will have a different landscape than what we are used now. We will lose these beautiful ices coming up to the sea as we see them today, but nature will find a way. I'm not worried about nature, but I'm more worried about the destiny of the full world as a climate system.
Chile has been working on glacier protection legislation for years, though progress has been slow.
Chile has been working on a glacier law for many, many years. We were the first to start, in fact. It was a colleague of mine, Gino Casasa, that proposed to start discussing a glacier law. It has never been concretized because of different discussions in the government, mostly on defining what is a glacier, that politics and businessmen don't see a glacier in the same way as glaciologists. So we haven't gotten into a concrete glacier law. But for example, what was good is that in Argentina, they took the same example and they created a glacier law just 1 year. It was in 2010, just 1 year after we started in Chile. So we don't have a law, but we were an example for countries like Argentina to create a glacier law.
However, Ines sees tremendous opportunity in private conservation efforts like the Route of Parks of Patagonia.
I see a huge opportunity in these ONGs and foundations that are focusing on conservation to help on the development of the science in this place. And I see many people moving towards these goals, and I see that Chile, it's concerned and it's starting to be aware of the amazing nature that we have. And I see people moving towards the good conservation, towards doing education and trying to regain all the knowledge from indigenous people that we have lost, that were more connected with nature.
When I asked Ines how she maintains hope while documenting such dramatic changes, her response was profound.
I'm not afraid of crises. I think that crises are opportunities. And if we see the facts as they are and we don't create ideas of what's not happening, then we have opportunities to act. If you go back to history, there have been many moments of crises around the world, and this is where the largest ideas have developed, because this is an opportunity to pose yourself questions and think in a different way and find new answers.
She sees her role as presenting facts to those ready to hear them and act.
My hope is, and what makes me not to be sad, is that I try to contribute a little bit to show these facts to the people that are ready to hear, and mostly, hopefully, people that are going to take decisions and that are intelligent enough to see the opportunity of this crisis.
Ines offers concrete advice for listeners wanting to help protect glaciers.
First, believe on the facts that I just talked about and try to make a change into using renewable energies so that we can have a global impact. Second, I would say go to Patagonia, because there you will realize what we were talking and how you felt and how I feel being in this amazing place that reminds us that we are so little and that nature is so strong.
Such beautiful advice. I completely agree. And hence why I'm doing everything with this series. We're fundraising, and I built a trip, and there's a whole bunch of good stuff going, girl.
Exactly. You're
trying to do my part. As our conversation with Ines draws to a close, I'm left with a strong sense of both urgency and hope. Her work reveals the stark reality of what we're losing. Ancient ice formations that have shaped the landscape for millennia are disappearing at an accelerating pace. Yet her perspective reminds us that crisis can be opportunity, and that nature's resilience offers lessons for our own adaptability. Standing in the presence of Great Glacier earlier in our journey, I could have never imagined the complex story each glacier tells, not just of its own formation and retreat, but of our planet's climate history and future. Through Ines's eyes, I've learned to see glaciers not just as spectacular scenery, but as crucial indicators of planetary health, water towers for ecosystems, and ancient archives of climate data. The ice fields I glimpsed from the airplane window represent both beauty and warning. They're reminders of what we stand to lose if we don't act quickly, but also demonstrations of nature's incredible power to create and recreate landscapes across geological time. What gives me hope is meeting scientists like Ines, who combine rigorous research with deep love for the places they study. Her decision to return to Chile to contribute her expertise to protecting Patagonian glaciers embodies the kind of commitment our planet's future requires. The Route of Parks, with its vision of connected conservation across Patagonia, offers a model for how we might protect not just individual glaciers, but entire watershed systems. By preserving large, connected landscapes, we give nature the space to adapt to changing conditions. Whether that means glacier retreat and forest colonization, or providing refuge for ice to persist in the most favorable microclimates. Next time on Rewildology, we'll wrap up our transformative journey through Chile's route of parks. From my first glimpses of Torres del Paine's granite spires to flying over these vanishing glaciers, this expedition has changed how I see conservation, connection, and our role in protecting wild places. Join me for final reflections on what the route of parks has taught us about hope, healing, and the future of our planet. Until then, I'm Brooke Mitchell, and this has been another adventure on the route of parks of Patagonia. I want to invite you to become part of something bigger than just this podcast. This series is actually one pillar of a larger initiative called Rewildology's Project Patagonia, where conservation truly meets adventure. Project Patagonia is built on 3 elements: listen, experience, and protect. You're already participating in the first pillar by listening to this podcast series. But if you're inspired to go deeper, you can join us in the field for the second pillar, experience. In April 2026, I'll be leading a small group of just 10 people on an unforgettable expedition to track pumas and explore the majestic mountains of Torres del Paine National Park. This intimate adventure includes expert-led puma tracking, meetings with conservation researchers, hiking through breathtaking landscapes, and even kayaking to the magnificent Great Glacier. You'll literally follow in the footsteps of the stories you're hearing in this podcast. The third pillar, protect, is where your passion can translate into direct conservation impact. Through our partnership with Panthera, the global wildcat conservation organization, your support helps fund crucial work to protect pumas and their habitats throughout Patagonia. Your donations help bridge divides between fragmented habitats, develop solutions for human-wildlife conflict, implement wildlife corridors, and support cutting-edge research. Whether you choose to listen to this series, join our expedition, make a donation, or all 3, you become part of a community dedicated to preserving one of Earth's most spectacular regions. To learn more about Project Patagonia and how you can get involved, visit rewildology.com/Project Patagonia. Together, we can ensure that the route of parks of Patagonia continues to thrive for generations to come.